Hi everyone, in this lecture we are going to be talking about sampling. So first of all, what is a sample? Well, a sample is a subset of observations taken from a larger population, and we do that so that we can learn something about the population. So there's a couple of terms to know, and let me just back up here for a second. When we talk about sampling, one of the things we're talking about is how participants are selected to participate in a research study. And because it's frankly impossible to sample an entire population of people, what we do is we select a certain number of elements or a certain subset of that population, and that population is our sample. So the components of a sample are the population, so that's the entire set of individuals to which study findings are to be generalized. And then the sample is that subset of the population. So, for example, if we were to sample, people in New York State, maybe we pick one person from each county or something like that to take a survey. Our population would be the people of New York State, and our sample would be the one person we selected from each county. And then the elements are the individual members of the population whose characteristics we are measuring. So the whole point of all this is to conduct a research study on that subset, that subset of the population, so that we can generalize back to the population. Generalizability is sort of a tough concept because the extent to which we can generalize really depends on the quality of the sample. And the word that we use to talk about how high quality a sample is representativeness. So how representative is the sample. Now, if we take our example from New York, for example, where we're taking one person from every county, could we argue that that's generalizable? Well, in New York, at least, you have, or could we argue that our sample of however many counties there are in New York, let's say 40, could we argue that those 40 people represent, the several million people that call New York State home? Well, that really depends, because New York State is a fairly diverse state. We have one of the biggest cities in the world, obviously New York City, and then we have some very, very small and sparsely populated or rural counties. So we might claim that we don't have much generalizability because our sample of 40 or so people doesn't really represent the several million who call New York State home. The formal term for the difference between the sample and the population is called sampling error, and ideally we want sampling error to be kind of as small as possible. This idea of sampling error actually kind of parallels this idea of measurement error. We want measurement error to be as small as possible. We also want sampling error to be as small as possible. So this idea of the target population is the folks to whom we're attempting to generalize. Now, the general sort of guideline is that we generalize pretty cautiously, because we always have to assume that sampling error is larger than we think it is. It's easier to achieve a representative sample if we have a homogeneous population. That means there's sort of less diversity that we have to sort of have to account for. So, for instance, let's go back to our New York State example. If we were to select one person from every county, like we've been talking about, the counties that are much more populated, say downstate or some of the big cities, there would be much more heterogeneity in those places, and so we would need to recruit more people from those places in order to account for that heterogeneity. Smaller counties, that we can assume that there's less diversity. It would be, and we would need a smaller sample to achieve kind of representativeness. When characteristics are overrepresented or underrepresented, those are just some sort of sampling vocabulary terms. If we have an overrepresentation of a particular characteristic, that means we have a lot of people with some characteristic, maybe a higher percentage of that characteristic in our sample than we might see in the general population. And underrepresented is simply the opposite of that particular characteristic is not as prominent in our sample as it would be in the general population. So there are two broad categories of sampling, and it's useful to sort of think about them in these categories here. So there are probability sampling methods and non-probability sampling methods. Now let me give you the sort of two sort of guidelines for how to interpret sample size. In general, the larger the sample, the better. And probability sampling methods are higher quality than non-probability sampling methods. So probability sampling methods are more likely to produce a representative sample than non-probability sampling methods are. Or put another way, probability sampling methods are more likely to result in a smaller sampling error than non-probability sampling methods are. So if you were thinking about sort of the quality of a research study, a higher quality research study would have a larger sample size and use a probability sampling method. We're going to talk about some of the different kinds of probability and non-probability sampling techniques that come up here, but what you need to know is what I just said about larger sample size and probability sampling typically resulting in a higher quality sample. And then you should know which of the sampling methods we're about to discuss here fall into the category of probability sampling or non-probability sampling. You don't necessarily have to be able to define these upcoming sampling methods, as long as you know whether it's a probability sampling method or a non-probability sampling method. So let's take probability sampling first. So we've got simple random sampling, systematic random sampling, stratified random sampling, and cluster sampling. So simple random sampling simply uses chance to determine whether or not someone is invited to participate in a study. Could be the flip of a coin, heads you're in the study, tails you're not in the study, something like that. It could be picking names out of a hat, using a deck of cards, something like that. A red card, you're invited to participate in the study. Black card, you're not invited to participate in the study. I don't know, something of that nature. So if we did that, sort of as the picture says here, we could flip a coin for every member of the population, and we would end up with our sample. In systematic random sampling methods, every nth element from a list of the population is selected. So what is nth? That's a number that you determine. So it could be every 10th, every 50th, every 36th element from a list or something like that. So again, if we were using systematic random sampling in our sample of people from New York State, we would need a list of everyone in New York State. And then, we would, depending on how big we wanted our sample to be, maybe we would take every 973rd person from that list. And that would give us a bunch of people that we could use as our sample. The thing that makes it tough about systematic random sampling is that it's very difficult to get a complete list of all of the people in a particular population. How would we accumulate a list of everyone in New York, right? We might be able to use the phone book, but not everyone's in the phone book. We might be able to use, a combination of phone book and census records and things like that. But there are people sort of, moving into New York State, moving out. People are children are being born all the time. People are dying. So that list is never fully complete. What do you do about people who are incarcerated? Are they technically part of the population or not? Hard to say. What about visitors or travelers, right? People who, who just happen to land in an airplane in New York City and are connecting to a flight, that goes somewhere else. Are they part of the population or not? So this idea that we could get even a complete list of people is kind of theoretical. It's fairly abstract. So a stratified random sample means that we have to know something about the population. We divide it into subgroups of exact proportion, and then we sample. We sample until we get an appropriate proportion. So again, if we were to do this from in New York State, if we were to do a stratified random sampling, we could make a list of all of the counties, and we would sample more. We would recruit more people from the counties that are more highly populated, and we would sample fewer people from counties that are less highly populated. And that would ensure a pretty representative sample. It would be tough to do because, again, you have to know something about the population. So there's a couple of different kinds of stratified random sampling. There's proportionate and disproportionate. You don't see disproportionate very often. Typically, you want proportionate because then that sample represents the population from which it's drawn. So, in this example here, this uses race, but you could sort of argue that the same thing could be done with different regions of New York State or something like that. So over here in this, if this is the population, if we were doing proportionate sampling, we would end up with a sample that proportionally resembles the population. And if we were doing disproportionate, we would end up with an equal or an equivalent number of people in the population. So to back up a second and illustrate, in this hypothetical population, the Asian race is very small. So they are in this disproportionate sample, they are actually overrepresented. And actually, come to think of it, the Black and Hispanic proportions of the sample would be too, since they're 25% of the sample, but 15% or 10% or 5% of the population. So they would be overrepresented. And then whites would actually be underrepresented here. So that's a good illustration of that idea of overrepresentation and underrepresentation. You might want to do this if you were especially interested in hearing about the experiences of people who tend to be underrepresented. And you're particularly interested in Hispanic or Black or Asian perspectives on a particular issue. So there's lots of good reasons to attempt to overrepresent a group of people in a sample. Kind of depends on what the research question is. So cluster sampling is the last of the probability sampling methods. So cluster sampling is useful when we don't have a definitive sampling frame, and so a sampling frame would be that list of every element in the population. So when we have clusters, that's sort of our best guess about what different groups in the population look like. And so a cluster is sort of this naturally occurring mixed aggregation of elements, with each element in the population appearing in one and only one cluster. So there's different sort of stages of cluster sampling. There's one stage and two stage, and that depends on how much you are dividing or subdividing or clustering that population. If you were, if it was one cluster, you might divide it into, let's say, sex. So you have men and women. If you had a two cluster, you might do maybe gender and over the age of 50 or under the age of 50. So you have men over the age of 50, men under the age of 50, women over the age of 50, women under the age of 50, and you could sort of do that as much as you needed to, and then you would sample from each of those different clusters. And if you sort of did it more, that would be multi-stage cluster sampling. So non-probability sampling is sort of that other big category of sampling methods. Now, we like probability sampling methods, but it's very hard to do. It requires some technical proficiency, some knowledge of probability, and you actually have to have access to quite a large population of people from which you can draw. So non-probability sampling you probably see more in some social work research because it's easier to do. It's more it's not as technically complicated, and it makes use of sort of everyone that you would encounter. So the four non-probability sampling methods are availability or convenience sampling, purposive sampling, snowball sampling, and quota sampling. Here they are. Availability sampling is just people who are around you. Availability sampling is, or convenience sampling is exactly what I used in my dissertation. So I was interested in surveying veterans for my dissertation. So I made a list of friends, colleagues, former students, contacts, family members, anyone who I knew in my personal and professional life who was a veteran or who maybe was connected to a veteran, and I simply gave them a link to my dissertation survey. I emailed it to them, and they were able to complete it or forward it on to people that they knew who were veterans. So I used a convenience sample. They were simply people who were around me. Purposive sampling is we are choosing respondents who have a certain characteristic. So I was interested in surveying veterans, and so I only surveyed veterans. So I purposefully sampled veterans. Anyone who was not a veteran was not invited to participate in my dissertation study. You see a lot of purposive sampling in social work research because we're often interested in the experiences of a certain group of people. So parents of a child with a disability, or a person in the criminal justice system, something like that. Snowball sampling is when one respondent refers another respondent. So I also did this in my dissertation. When I found a veteran who was willing to participate in my study, I asked them to forward the link on to someone else, other veterans that they knew, and in that way I was actually able to get just about 400 veterans, which was kind of cool. So in quota sampling, quota sampling is simply knowing certain characteristics of a population and attempting to get that same proportion. And actually, it looks very similar to some of the random sampling methods, but we're actually in quota sampling using convenience or snowball methods to to get to a certain proportion. We're not randomly sampling to get to a certain proportion. So again, the thing to know about sampling is that the larger the sample size, it typically results in less sampling error, and the larger the sample size, the more confidence we can have in a small sampling error, and the more confidence we can have in our generalizability. So depending on the homogeneity or the similarity of the population, we can sometimes get away with smaller samples, then we would need larger samples. But if a group is particularly heterogeneous, that is going to increase our sample size. The more subgroups we want to examine, the more sort of divisions we want to make in our sample, the larger the sample size must be. So sometimes you see this thing called a confidence interval. A confidence interval is sort of a way to determine the upper and lower limit of a particular estimate or conclusion. And usually you see a 95% confidence interval, and essentially what the interpretation for that is how confident can you be that you would get similar survey or similar results if the survey were repeated. So if the survey were repeated, you might see results within this sort of 95% confidence interval, which means usually there's a score slightly above or slightly below what it is we obtained. Margin of error is the amount of sampling error that can be tolerated. And you see this a lot in political polls. They might say a 5% margin of error, a 10% margin of error, or it's usually not 10%. That's pretty large, but maybe 3% or 4% or something like that. So if in a political context, if a certain politician had a 40% approval rating or something like that with a 5% margin of error, the interpretation would be he or she, this politician, has a 40% of approval rating, but that might be as high as 45% or as low as 35%. So it's 5% on either side of the estimate. If, for example, a politician had a 50% approval rating with a 3% margin of error, then the approval rating might be as high as 53% or as low as 47%. So sometimes in political rhetoric, they'll say that some person is favored to win an election, and it's outside of the margin of error or something like that. So they might say, this person is favored to win, there is a 60% chance of winning with a 3% confidence interval. That might mean, their chances of winning are 57 to 63%, but the other candidates' chances of winning are 40% with a 5% margin of error. So that would go as high as 45 and as low as 35. So the low end of the one candidate does not overlap with the higher end of the other candidate. So when you have political races that are sort of outside of that margin of error, that increases our confidence in our ability to forecast the result. But as with anything, predicting the future, especially in politics, is a very difficult task, and there are plenty of times when polls and forecasts are wrong. So they're simply our best guess with the available data that we have. It's not it's not error-free or sort of absolute truth. So, a couple of closing comments. What is it that you need to know about this? You need, about the material from this week. You need to know what sampling is. So sampling is how participants are recruited to participate in a study. And then you need to know what probability and non-probability sampling is. and which of those sampling methods falls under the category of probability sampling and non-probability sampling. If you can do that, you're in good shape. So I will leave it there. As always, thanks for watching, and feel free to be in touch if you have any questions.